What are real numbers? A real number is a rational number, and it can also be an irrational number. A rational number is a number that can be written as a fraction. Oftentimes, it's written as a symbol q, and it's used to stand for quotient. An irrational number is a real number that can be written as a complete ratio of two integers. Some examples include pi, Euler's number, the golden ratio, and the square roots of any non-perfect squares like square root of 2, the square root of 3, and square root of 5. Irrational numbers can also be expressed using decimal expansions, which literally just means decimal. When people say number, they are usually referring to real numbers. Real numbers can be shown on the number line. The symbol for real numbers looks something like what you see in the upper right-hand corner of the slide. It's like a fancy R, or sometimes people will use a bold R. Some real numbers are positive, they are bigger than zero. Real numbers can be thought of as an infinitely long ruler. There is a marker for zero and every other real number. There is also numbers before zero, unlike a real ruler. The numbers before zeros are of course called negative numbers, and they are denoted with a negative sign in front of the integer. Wikipedia states that there are no empty spaces between real numbers and that there are infinitely many real numbers because there is no biggest and there is no smallest real number. It says that no matter how many real numbers are counted, there will always be more to count. It goes on to say that there are no empty spaces between real numbers, which means that if two different real numbers are taken, there's always going to be a third real number between them. In this example below, you see a number alpha, denoted as 1.02, and number beta, which is denoted as 1.03, and it would appear that these numbers are just about as close together as you can get. But as we see with number gamma, which is denoted as 1.001, it's between both numbers alpha and beta. The real numbers are said to be uncountable, which means that there is no way to put all real numbers into a sequence, even if the sequence is infinite. This makes real numbers special because even though there are infinitely many real numbers and infinitely many integers, there is said to be more real numbers than integers. Another way to look at this might be with proportions. So written out on the bottom here, this is not standard mathematical notation, but this is just a way that I like to think about it. So because there are said to be more real numbers than integers, a way to look at it could be with proportions. So integers are proportional to real numbers, such that the real numbers are greater than integers. This idea is often expressed by saying that integers are countable and that real numbers are uncountable. There are some simpler systems inside of real number systems. For example, rational numbers and integers are all considered to be real numbers. There are more complicated number systems than the real numbers, such as complex numbers, which we'll get into in another video. Every real number is a complex number, but not every complex number is a real number. We'll elucidate more on this later, though similarly, 3 over 7 is a rational number, but it's not an integer. There are different types of real numbers, and sometimes all of the real numbers are not talked about at once. Sometimes only special, smaller sets of them are talked about. These sets have special names. Namely, they are natural numbers. These are numbers that have no decimals and are bigger than 0. Think 1, 2, 3. Whole numbers, which are positive real numbers that have no decimals and include 0. Natural numbers are also considered to be whole numbers. Think 0, 1, 2, 3. Integers. These are real numbers that have no decimal expansions. These include both positive and negative numbers. Whole numbers are also integers. Think -2, -1, 0, 1, 2. We can go on. Rational numbers. These are real numbers that can be written as fractions of integers. Integers are also rational numbers because every counting number, think 1, 2, 3, and so on, has an invisible 1 underneath it, right? So think 1 over 1, 2 over 1, 3 over 1, and so on. Transcendental numbers. Transcendental numbers cannot be obtained by solving an equation with integer components. The most famous example of transcendental numbers are pi, the ratio of a circle's circumference to its diameter; Euler's number, the base of natural logarithms. Finally, irrational numbers. These are real numbers that can be written as a fraction of integers. A fraction of integers is any number that can be written as a ratio a over b, where a, the numerator, and b, the denominator, are whole numbers. In other words, a and b are integers, and b is not zero. Transcendental numbers are also irrational. Examples: the square root of 2, the square root of 3, the cubed root of 47, pi, Euler's number, and the golden ratio. The number 0 is special. Sometimes it is taken as part of the subset to be considered, and at other times it is not. It is the identity element for addition, which means that adding 0 does not change the original number. For multiplication, the identity element is 1. One real number that is not considered rational is the square root of 2. The square root of 2 is considered to be irrational. See, because if you draw a square with each side being 1 unit long, then the length of the line between its two corners opposite to one another is said to be the square root of 2. And I drew a little image of what this might look like. So here's a diagram that can hopefully help you abstractly grasp what's going on here when it comes to all of these different names and categorizations of numbers. Thank you so much for watching, and it's important for me to go over my resources because I did heavily rely on this Wikipedia article on real numbers, and I use Google Slides to make this. So these are my resources, and thanks for watching. Have a good day.